Today I'm going to present about a solution that we are trying to solve a burning problem in our organization. We named this talk Rewind and Restore because that's what we are trying to do. We want to travel through transaction and then fix some corrupt data. Okay, so here is the problem statement. Customers come to us saying that they accidentally deleted important records and they want us to restore it. Okay. So Barbara says that we don't make mistakes. They are just happy little accidents. These are not happy little accidents. If I'm maintaining the application, think about it. If you lost your data from your database, how will you get it back? So in a large organization, if you have an enterprise application that you are maintaining, they always have backups. But even with backups, how are you going to solve this problem? You have to know what data the customer deleted, and these data are not simple. If you make an update, if you make a delete, they will have side effects. That is what I mean. So if you have a large system, distributed application, any action the customer or end user does, it has side effects. This is a boring, one of those boring UI that we have, like Freshworks is the application that I work on. It has a ticketing module. Okay, if a user adds a note to a ticket, makes an update to a ticket, they will have lot of side effects. For example, a ticket is associated with workflow. What does the workflow do? It lets the customer do a lot of things. It lets them call another applications. It makes the customer make activities based on the kind of updates that you do. So what I'm trying to say here is any small action that you do, they will have side effects. Okay, so as a preventive measure, how will you solve it? For example, if I'm deleting, if I'm allowing a user to delete a large number of users or any module, you will not actually delete them from your DB. You will provide a soft delete option. Basically, anything the user does, it goes to a trash bin, and they will get an option to restore it from their UI itself. There is also another solution which is straightforward, which is data versioning. Any updates that happen, any deletes, any updates that happen, you just, instead of updating the record, you will just create a new record with a version. So these two solutions kind of solve the problem, but they will not solve all the problems. For example, if you have a say you have soft delete across all the modules that you support. You have users module, you have tickets module, you have solutions module. Assume that you support trash bin for all of them. Okay, how will you solve bulk updates? If you select all the users in your application and then update their names, update their emails, customer says I made a wrong update, now I want it restored. Think how will you solve that problem? A simple trash can cannot solve this problem. Similarly, think of any application. If you do updates, based on the update, the associations can get deleted. The otherwise, if you delete some data, it can have other associations where you can do updates. For example, you can have a module like user module that has fields. Okay, now I delete the field. I'm only doing a delete operation. Okay, I can have soft delete where I will say I won't actually delete the field. But you have millions of users who are built based on the specification, based on the user field specification. In there, say for example, you have a department field. The department field is deleted. Now, the data, the users associated with this department field, they will all get nullified. So, which means those data are updated. They are not versioned or they are not moved to a trash. Okay, so also even emptying a trash, customers, if you give a trash bin, customers will simply empty the trash as well, and then they will again want you guys to restore it. Okay, I'm seeing some smiles in the audience here, looks like this problem. They face this problem as well. Okay, so if a user says that hey, I made this. I accidentally edited something, or I made a large update and now I want it restored. What do they mean by they want it restored? Say for example, a customer deleted a bunch of users yesterday at 12 p.m. Now they are reporting to me, hey, I want them restored. What do they mean? They don't want to go back in time. They don't want to go back because lot of things happened after they made the wrong delete. Good transactions happened after their bad deletions. Okay, so they still want to keep all the good transaction, but the only corrupt transaction they did yesterday, they want it restored. So which means I cannot simply make the application go back in time. Hey, here I went back, I time traveled. Now you have, this is the data you have. You can continue from. I cannot give that as a solution to them. What they want is I have to go back, rescue the transaction, and then fix it. That is what they are expecting. All right. So transaction mean a lot of things here. So I have to define the transaction here because each single database update can be a transaction. So what I mean by a transaction here is a coordinated set of operations. So for example, transaction 1 is users being updated. User's name is updated. This in turn will have a lot of side effects for this transaction. Then there is a create user, that is a transaction, but this has lot of side effects as well. So whatever happens within this action, they are considered as transactions. So in transaction 3, user deleted a wrong user, and then in transaction 4, they corrected their mistake and they deleted the correct user. But still, the effects of transaction 3 will still be there, right? So this is what we mean. So transaction 3, where a corrupt transaction happens, then the application continues with newer transactions. Now it is our job to fix the corruption. All right. So the solution that we are proposing assumes that we have all these mechanisms that in a large distributed application, you have logging, you have tracing, you must have data backups depending on how much cost you are ready to spend. For example, I'll go through the steps here. These are fundamental steps. Let's go through them. Okay. So logging. Logging means your application by default comes with some logging, but what I specifically mean here is you need to have a log of whatever changes that happen to your database. If it's an update, if it's a delete, if it's an insert, whatever kind of data stores. You might have data stores like MySQL, Redis, or other NoSQL DBs. So the logs that the solution is only as good as the logs that we have here. So what I can do is I can write my own transaction log. I call it transaction log mining. Basically, you write a custom plugin in your application where you mine everything that changes in your database. But there are also there are also open source tools available that takes care of this. For example, OpenTelemetry's observability framework. It provides tracing like this, where you will get comprehensive information of what happens within each microservice. Okay, I'll come back to this slide. So OpenTelemetry is just one example. You can write your own, or you can find other alternatives as well. But OpenTelemetry just works fine because it's based on a OpenTelemetry specification, which is also open source. So yeah. So then tracing, logging and tracing are just same step. Basically, first you log the information, and then tracing lets you know what are all the changes that happen within this transaction across a distributed application. If you have 1,000 microservices, you need to have a tracing that looks like this, that tells it what changes at each level. Okay, and the thing is, this is also available already. It's the matter of you plugging these things into your applications and then making it work. That is the library that is available for OpenTelemetry. They went to the painful process of supplying these all. Us plugging is the work that we have to do here. All right, assume that we have this as well. This is a tracing here example. There is some front end here where a purchase order request is made, and that in turn calls a bunch of microservices. There is also a Kafka listener here. So with tracing, you will get this comprehensive information that you need. So right now what you have here is, you know what changed within a transaction. All right. So based on the tracing that I had, I wrote a custom application where I extracted the information that I want. This UI is built by me, so that is why it does not look great. For example, I have a transaction ID here, and then it says that, hey, you deleted a category here, that is the operation, and then it gives me a timestamp, tells that when it happened. And I extracted only the MySQL queries, but you can assume that as long as I have this information, I'll be able to get all the data I want, all the changes that happen to my database at what time I have this information. So with that, uh, with that comes the next step. So when I said time travel, what does it mean is we have a corrupt transaction that happened here. We have a corrupt transaction that happened here. I know what time it happened. Now, all our data backups, so data backups is something you have in your enterprise applications where you choose, I want minute level data backups or hour level data backups, which you should have in our enterprise application. So I'm assuming that you have that also. All right. So transaction 3 happened at a particular time. Now I need to boot up the backup DBs just before the transaction. All right. So coming back. So I know the time, it says 1 month ago, but I don't think organizations will have backups for that long. Maybe 1 week or a fortnight, that makes sense. So you have to boot up your DB just before this time. All right. So that is what I mean here. So this will become a source data. Now you have a data which is not corrupted. I mean, just before the corruption happened. All right. So now you have to reverse the operation. So I booted up the data stores, which has data which is not corrupted, and there is also a live production database which has corrupt data. So you know what operations happened here. All right. So first I deleted some group accesses. First some group accesses got deleted. Finally, the solution category got deleted. All right. So when you want to restore this information from the source DB, you have to get the data that got deleted. Also, you need to execute this in reverse order. Because your databases will have foreign keys if it's a relation database, and you cannot directly insert the first one here because the foreign key wouldn't even exist. All right. So if an operation happened 1, 2, 3, you have to execute the reverse operation in 4, 3, 2, 1. All right. So that is what I mean. You have to execute the reverse operation for each change. If an insert happened, you have to delete it. All right. If a delete happened, you have to insert it. So the left side is on the target DB. This is on the source DB. This is from the left side is the you have to execute the right side in your target DB. All right. The update case is basically you have the corrupt data in your live DB. You have to get the correct data from your source DB and then update the correct data. All right. So whatever I have shown here as steps, right? They are for each microservice. They are for one microservice. So for microservice actually. So for one microservice, you are doing all this option. So but you have a distributed application. It means a lot of microservices talk to each other. That is why you need to do the similar operation in all of them. Okay, but the ordering is important. Say for example, you have a customer facing application where customer says, hey, create this user. All right, the user gets created and it talks to a lot of microservices. For example, there is a search platform. So the data from the customer facing application goes to the search platform. Now data is written there also. All right. When I'm restoring them, I have to go through these phases where I restore in all these microservices as well. Like I said, for executing the queries in reverse order, I should do the same thing for executing the whole operation itself in the reverse order of microservices. That information I will still get from the tracing, because the tracing information knows when each operation happened. So I should find the services where the last operation happened and then restore it from there. All right, moving on. So I put some phases here. Basically logging, you know that either you write the logs or you use some open source tool that is already available. Then there is the prepare phase. All right. The prepare phase, what does it do is, this is what takes care of identifying which transaction I should revert to, what time I should revert to, and then I have to prepare something called a restore statements. All right. So for each of the services, these are the changes that happened. Hey, this is my restore option, restore statements. All right. Then you will need something called an orchestrator that takes care of calling, executing the restore operations in each of these microservices. So that is what it is doing. The orchestrator will identify the order of execution. Then I'll iterate over each microservice. Then the whatever solution that I gave will execute in each of these services. All right. So reverse changes is basically the reverse operation that I have to execute in each of these services. You have to also understand each of these services will have multiple data stores because they are most probably a polyglot. You will have a MySQL DB, you will have a Redis DB, you will have a Memcache maybe or Scylla DB. You will have a lot of DBs within a service. So you have to iterate through your services. Within each service, you have to iterate through your data stores to restore the operation. So once each service is executed, the next service should start executing. All right. So here is the architecture diagram how we will solve it. Basically, this application can be more than one. I just put it simple here, but it will be a large microservice, and you will have a lot of applications here. All right. So every time application something changes in the application, they get returned to a time machine log, and then there is a log listener that sends this data to a central time machine application. So this part is already available in through open source mechanism. It's just a matter of you plugging them. Once now correct transaction is identified, and then we are saying, hey, revert the transaction. This time machine takes care of booting up the databases, preparing the reverse operations, and then the time machine should not directly execute these reverse operations here in these applications, because that is what you want, right? You want your application to be secure. We cannot simply let a third application to directly execute queries on your DB. So that is why I meant there is a prepare phase where I will prepare all the reverse operations, but I won't execute it myself. We have to share it with the application to execute them. Let the application decide how they want to handle it. For example, I said this is simple, right? You are doing an update. Now think about it. Updates can have conflicts. For example, for a user, you deleted a department. Now the user's department is nullified. Now a later transaction updates a different department to the user. When you are restoring this information, you will see, okay, I want to update, I reinserted my data departments. Now I'm about to update the department field to the user, but they have a different department. What do I do with it? That decision our time machine cannot take. We cannot take it because that is a domain specific information. So that is why we have to leave the application to implement that. We have to give the application the mechanism to restore it. The applications can either choose to not handle that conflict. Basically, any new update happens after that, it looks like a valid update to me. So the application has to decide whether it is valid or invalid. All right. So that is why I'm not directly executing the reverse operation from my time machine itself. I just tell the application, hey, these are the deletes, these are the operations that happened. This is how you restore. I booted up the DB that you need, source data that you need. Here is all the information. You take care. All right. So I have put together a demo for this one last night. I'll show you. So this is Freshservice, the application that I work on. So what you see here is a knowledge base. A knowledge base is simply solution articles that if you go to, any of your service providers, like for example Airtel, if you face an issue, they will first step is they will point you to a solution article. For example, if you ask, how do I port from Airtel to Vodafone, the first thing they will point you to is to a solution article. So this is that agent facing side where they create these articles. So if you notice here, I have some important documents category and then some unimportant category. What I will do is I will create a new one. I am creating a new category named is that a word, unimportant? No. Folder. All right. All right. Okay. So this is my local. So I need to do the backup myself, but in your distributed system, you should have this as automated, all these backups. So now I'm going to run a script that will do a backup for me. So the script might take like 30 seconds to finish. So I have a DB called ITIL disk. I'm doing a backup now. It will create a backup of this DB called ITIL disk underscore BKP. That's what's happening right now. While the backup is happening, you should also notice that I wrote a custom logger where all this data are being logged in. Any changes that happen to the DB are being logged in here. So this is written to a file, but if you use OpenTelemetry or any other mechanism, this will also come out of the box for you guys. All right. So the backup is complete. All right. So now the corrupt transaction happens. What I'm going to do is I'm going to delete I intend to delete the unimportant category, but instead of deleting that, I'm deleting the important category because I'm making a mistake here. Okay. Important documents. So I deleted this and it is gone. Important category is gone. I have a UI here. All right. In my step, I also said that whatever currently everything is written to the time machine log, but the data is not pushed to time machine, which I'm going to do right now. This is also automated. This should also be automated in if you are implementing this. So I'm pushing the data. I'm pushing the logs from my time machine log to my time machine service. That happened right now. So if I go here, reload the page, you will notice that. The information I created are here. For example, this is the transaction where I created the unimportant article. This is the transaction where I where I published the article. This is the one where I deleted the wrong category. Okay. If I click on this transaction, you will know the time it executed, which DB it is executed, and the data, the transaction that happened within it. I gave a simple example here, but if you are implementing this, you will see a large number of queries from multiple data stores. All right. So if you see that important documents is gone. Okay. Now I'm gonna click on revert. It happens quickly because this is my local environment. So I think it's already reverted. Okay. So I'll go back and reload the page. You will see the important documents is back again. Okay. So like I said, this is just a very simple example, but the idea I have shared here will work for any complex updates, that cause updates that happen over multiple microservices. The idea that I have shared here will work for that as well, and that we are in the process of implementing this as well. All right. I think that is all I have. Do you guys have questions? Yeah. Yes.
So that also you will not have unlimited versions, for cost and other things.
That is correct. So you have to decide how much you want to spend it. So we have this solution because customers are ready to pay for us. They are saying that, hey, we want this, we are ready to pay for it. So give this feature. We tell them like we can restore it in our application, but we cannot go back to other microservices and get their data. But customers are willing to pay for it. So you have to decide in that way. If you are looking for cost, maybe decide a day. Like we in our organization, we do 7-day backups. That is good enough time for them to report the corruption.
Okay. Can I ask one more question? So you're going to send the information back to the application and let the application do the revert,
yes.
Right? Now, since it was not mentioned here, I had a question. If there were failures there, because that is a transaction, and it could be complex because it could be a distributed system and span across multiple microservices, right? So if there is a failure happening in that revert, how would you handle it? Because that becomes a really complex use case, right?
Yes, yes. So there are two ways to solve that problem. One of them is while logging, okay, first of all, I'm going to talk about the corrupt transaction that is caused. Okay, if you delete, uh, say for example, you uh, deleted a user, okay, and the user might have millions of associations, and all of those data are deleted. So why am I logging the operations instead? I could log the data itself, right? If a user is deleted, I can log the data itself, and their associations data also I can log. But the problem is, if your association has millions of record, you will have to write that much data in your login, which increases the cost drastically. But when you are restoring it, that is not a problem. While restoring it, take for example, MySQL is an it is ACID DB, right? So you can execute these queries in reverse order. You see a failure, you can totally revert everyone. And even if something commits in your DB, you can revert the data, because in this case there is no if there is no the deletion. Here we are trying to insert. Only if I am trying to delete the data, I need large data logging. In this case, that problem is not there. In any other case, our organization recommends do a complete revert. Just don't try to fix it. Just completely revert it and then start over.
So you basically don't commit till the complete transaction succeeds.
Yes,
right?
within a data store.
So you also prevent incorrect reads
Yes.
during the course of your revert.
Correct.
Okay, one final question. So you did mention about corruption of data, right? Like they are doing the incorrect action, and subsequently there may be actions on top of these actions, and you mentioned that, right? I did not understand that clearly as to how you'll be able to restore that. Now let's say there's T1 and then there's T2. That depends on the outcome of T1, right? You are given the input of T1. How would you identify that T2 is now linked with T1, and then how would you correct the ripple effects of T1 on T2 now that you're reversing T1?
Yeah, so the idea here is, this is a Hail Mary. Customer lost some important data. So there could cases arise where it is unsolvable, where we have to put the manual effort into solving them. So right now what we have decided here, if there is a conflict arises, we don't solve it. If the application knows how to solve it, let the application do it. So we have to live with those kinds of limitations. Yes.
I had one question.
Yeah, go on.
One thing is regarding the pointing time DB. Do you spin it up only when the revert action is triggered, or is it always available?
The point in time, if it comes with the if we are using AWS, it comes with MySQL DB, right? So if it does not come with it, there are backup options are there. But point in time DB gives you minute level accuracy. Assume in your distributed application you have a lot of data stores, and some of them are backed up on an hour level. Point in time does it in minute level. You have to find the common time where you can get the data. So if the data is not there for 1 hour, it means that it is a contract that you have with your customer saying that, hey, I have only this kind of granularity, and that is what goes into the agreement.
I had one more question on the operation that you mentioned, reversing the operations.
Yes.
Right? That is prepared by you and given to the application as a guidance that they can then execute.
Yes, I will. If I'm saying that you have to insert this operation, I'll tell them that, hey, this is your source DB. Select these records from here. Now you have the information. You can choose to insert it. I can also give them a library that does it. But if they want to override it, they can do that.
How do you handle IDs, primary keys? Because if you delete, if you have an auto serial on the DB, then if you do a new insert, the ID will change.
Yeah, so we are assuming that once the ID is created or deleted, the same ID wouldn't be created. So the ID should always be an increasing number. So if they deleted it from my backup, the same ID will be there. I'll insert them.
But wouldn't that break order if there's already new entry?
Can you give me an example?
Like let's say you were at 100 and then the bad transaction happened and then there's 110, the serial has moved to that. Now when you try to restore, are you trying to insert back the 100 record, or are you doing 111?
No, 100 only.
100. Okay.
So it won't affect it. There are also operations that happen like update set position equal to position plus 1. It's not actually doing and giving you an ID. Where in the where condition you will say, in the update case you will say update position equal to position 1 plus 1. But if you think about it, I have the source data. From the source data, I can restore exact data actually. So that wouldn't be a problem.
Yeah, hi sir. I have a question.
Hi, go on.
You said that this was an third-party library, right?
Yes.
So is it any way that our data will be exposing to that company?
No, it's an open source library that you have to host. Anyone can use it. You have to host it from your side. The
Okay,
data is not exposed
because
to
we are
them.
exposing all details that from the database to the table's name. So it is an log capturing platform. I am thinking that they will also have a nested log for their platform library. Like,
These are hosted locally. You have full control of hosting it. It's just
okay,
the code is open source. You can deploy your own code.
okay. So that third party
It
company
won't
doesn't
leave
have
you.
access
Yes.
to any data. Okay.
Yes. There is a question.
S- this is-
Mike.
So basically, so there's the time machine application, right? Does it create a replica DB and goes back in time like from the backup?
Yeah, I mean, it does not. These are already available popular solution. With each of these data store providers, they are providing the way to do the data backups. We need to have these mechanisms in place where the data backups are happening all the time. But the actual data backups that is provided by the data store providers itself.
So I was wondering, so it's like, let's say one user does like a bad transaction, right? For that one user, isn't it too expensive to go to a backup and then do those transactions and then revert that bad transaction and continue over the new transaction and then send it back to the application, the main application to handle?
Yeah, it is costly, yes. The thing is that is why customers say that they like their data integrity and they are willing to pay for it. So if you are trying to solve this problem, you can take various measurements here. For example, if the customer is ready to prepay for it, you can consider them as your premium customers, where you will try to provide this end-to-end distributed tracing and all these backups. You can set that for those customers alone.
So this reversal of data is not available you'll have the customer will have to request for it and then they'll be able to.
Yeah, they know that. See, some of the cases that we face here, right? The customer, they don't even know that they made a mistake. They go through the operations and then they report to us on a later date. So since we have these backups I mean, we say that if you come to us after 7 days, we cannot do anything. So, but we have to have these limitations to support this
Okay.
in
Thanks a
terms of
lot.
cost. Yeah. Anyone else got questions? Oh, okay, there is one.
Hey, so I wanted to know, what would we be having any downtime when you're performing these transactions once again? So, what is there a way to throttle the transactions that are happening? Suppose we have a very huge transaction, a lot of records are deleted, and if you want to revert all of them back, so having them on a live application, is there a way we can throttle?
We cannot throttle because customers application cannot be disrupted. It's like a heart surgery.
Yeah.
You have to do it. That is why it's so delicate. But that's a great question. We had this question. We wanted to know. Say, for example, if they say that I made a change in this module, can I just prevent him from making any changes during this happens? I cannot do that. I cannot afford to do that.
That's right.
Hi, I'm here. I have a question. My question is whether this third-party API is only applicable to only relational databases or any kind of databases.
It is it's very good actually. They did the hard work of doing it for every programming language, every popular programming language and popular frameworks and popular databases. So it will be available. OpenTelemetry is available.
Okay. If another question is, if I delete a record which is a primary, a foreign key, then what happens? Like how we can restore it?
You are talking about the times are generated at runtime. How will I restore, right? If you think about it, in your source data, the exact time will be stored there, right? When I'm restoring it, say for example, I'm updating back the data. The source data will still have the correct time actually, whatever. Whether it's a time function or any function you have, the source data will have the data, so you can restore it. Any other questions? There is one.
Just two-part question. So I think in this case we are talking about like basic SQLs being fired directly, right? let's say like I'm using some kind of an ORM, let's say like Hibernate in this case, wherein my SQL construction is automatically happening and I'm not doing any kind of SQL management in the system. So in that case, I can still extract the SQL logs, but let's say if it has more complex operations, like wherein like I'm dropping and cascading the effect to all the foreign key tables, etc. In those scenarios, I won't be able to map to what and all tables got dropped also, right? Because that is a transaction which happens at the DB level and not really from the application side. So in that case, how do we do the reverse transaction?
Yeah. So we don't directly propose that we have to run the queries directly. We have to give the mechanism to the application. If it's a like Spring Boot application, we have to give them the mechanism saying that, hey, this is the table that is affected. These are the columns that are affected. For this table, you will have a mapping in your ORM application that you can execute. What I can do is I can build a generic library for Spring Boot framework saying that this is the generic way of solving it. If you want to override a specific case, that you can handle. So we cannot directly execute scripts. That is just a simple example I showed, but we cannot do that.
That's what. So because in that case, basically, I'll have to override and have specific logics for each of those transactions which I'm looking at.
Generic logic we can build and then provide it for each framework. But if they want to override, they have to. We can give them the freedom to do it. We have to.
Understand. So in that case, essentially, we'll have to have some kind of an implementation over and top of the library to specifically revert those kind of transactions which I'm looking for.
Yes. So this thing is definitely always needed because the application it's not always a simple CRUD application, right? They have side effects. So we are enabling these applications to do this operation to do the revert by themselves. There will be complex. All applications are complex, kind of complex.
Understand. And just one more, again, the follow-up for this one. So let's say like in this scenario, basically you are stating that like you'll generate a generic SQL as such and you'll pass on that as an execution option for the main application to basically execute. Right? But if I don't have the functionality to directly fire SQLs as a part of my main application, then in that scenario, how do we go ahead? Because in, let's say like financial spaces, you don't have direct functionalities to fire SQLs, right? So
So again, we don't want them to execute SQLs. We have to enable them to do what they want. So even the data I share with them, it will be a large object that looks like a JSON. It will tell them this is the main query that executed. To revert this, here is where you can get the data, and these are the columns involved. From the columns involved, you can implement your own mapping. So I'm against implementing these SQLs because you might have cache data. So just reverting the data from the DB will not solve that problem.
Exactly, because again, if you're having one more layer of caching between the DB and your main application, then in that case, you're not exactly reverting the data in cache, right?
Correct. So the idea here is to enable the application to implement it. We can provide a generic solution. I can create a library that is pluggable in these applications. They can go with the generic solutions if they like. If they have specific way to solve each problem, we have to enable them to do it.
Understand. So essentially, if we can summarize it, then it's more like a set of instructions which you will be passing on from your time machine API to essentially your main application that can be followed up, and you can have one more implementation for that as a part of your main application.
Yes. So we have to do the heavy lifting here, making it as easy for this application to revert it. But we cannot directly say you have to implement it, you have to run queries to resolve it. We cannot do that.
Understand. Yeah. Thank you.
Any other questions? Yeah, I think that is it. Hey, thank you.